Okay. So today, hope you are clear about what we discussed so far, object and class and how you can implement them. It is one of the base behavior of the object-oriented programming. So far, we have just created a class and then we were creating objects and additionally, when you are implementing the logic, so you can do something called constructing, like during your object creation or construction of your object, if in case you want to assign any values, you can create constructor. And but in Python, we call it as a init. So that is a to assign the default values for any members. That could be member variable or even member method. Okay, so today we'll start something about inheritance. So the name itself inheritance, right? If when you look at, so inheriting the property, say for example, you have any properties of your grandparents, so the property will be get automatically inherited, provided checks and balances conditions apply there. So here also, in what context, okay, inheritance can help. So the name itself very common. You don't need to maybe search for the definition of the inheritance. Means inheriting the parent behavior to the child means okay, you can develop one class, okay, and then all that class behavior. So here in general outside we will inherit the properties, but here what is properties like everything, whatever you have defined, whatever logic you have defined in this class. This class I want to inherit to a different class without rewriting it. Okay, say for example, class I'm just saying say P. Just for example, you can treat it as a parent. Let me say P1. Say this is the parent one. Okay, now I'll say very simple. A simple variable, that's it. Again, like this, since it is a class variable, okay, so you should understand the behavior of it, but that's okay. So we have defined one class P1, so we have defined some variable. So now I want to maybe define one more class, means I am planning to develop one more class. So this class I am planning to have only few details. Okay, and then I'm going to develop one more class, child1. Okay, and then in this child1, I am planning to develop a few more details like so now both are different classes and now in case I want this, let's say in some scenarios, this code I want to use in this particular class. So now both are different. I can create an object for P1, I can create an object for C1. And but if I want to use this behavior or these properties in this particular class, so currently it is not possible. So you can use it independently 100 times. You can create objects for P1 and you can create objects for C100 and then you can call them, use them. But in case you want to use this behavior into this particular class, okay, directly not possible. And that will happen, that can be done through this inheritance behavior. It's very, very simple. There are multiple ways of inheritance. Means you can inherit one class or multiple class. That is called multiple inheritance. That varieties we can see later. But today, we'll see what is inheritance and how we can implement it. So this is generally in terminology, right? So this is called parent class, okay, from which you are planning to bring the behavior to the child class. So this is the parent class and this is the child class. Or you can say, so this is the base class and this is the derived class. So this is your base, and then you're deriving this base here, and then you are implementing something. So parent, child, okay, base and derived, any terminology you can use it. So, but how we bring this behavior to here, or how we inherit this behavior here, is very simple in Python. Putting this class here. Okay, if it is same thing in Java, so this is a behavioral. So same exactly. Inheritance in all the technology, all the programming languages common. Maybe slight modifications will be there the way how we implement. The syntactical, if you see, class C1 and extends P1. Okay, we are extending the C1 class from the P1. So this is a Java syntax. Okay, and there is also something called implements. Okay, these are all different varieties in Java. Okay, but Python will make our life very easy mm, in terms of the syntaxing, writing. Okay, it will make our life easy. See, if it is very simple, so it is class C1 and then you are trying to inherit from the P1. Okay, so now before inheriting how it is, and then I can show you. Now first I'll try to create object 1 equal P1. So obj1 dot, so parent grid, we have this parent grid, it is directly coming. Now I'll say obj2 equal to C1, obj2 dot child grid. So when the moment I put tab, it is directly taking this variable. So both are currently independent. So if I want to use this, I want to create object for this. If I want to use this, I want to create object for this. Maybe here is only one variable, it doesn't matter whatever you do. But if you are writing bit complex logic here, so then all that matters. So this we no longer require. And also, even if you do, I'm not able to put them together in place because it is independent, but taking them together, it is not possible here. So here I'm simply keeping P1 class here. So this is going to be child class and this is going to be a parent class. So we are inheriting C1 to have the behavior of the P1 here. So now this time I'm creating an object C1. So I'm creating object for C1 only. Now we can see obj1 dot when I say you are getting 2. Previously when I put dot and then tab, it was taking only 1 only directly. Now you can see I have created object only for C1 and you can notice you are getting 2. So here what is happening? So you have a child class. So we have created object only to child class, but you can notice it got inherited all the methods, information what we have defined in the P1 into C1. So this is exactly simple way of understanding the inheritance. You are inheriting the properties of your parent class into your child class. So now you don't need to worry about the P1 here. If you create, even after doing this, if you create object to, even still you can create object to P1, but this will have only parent. It will not have. So if you want to use only this behavior, this class you can continue to use. But you are interested to use a different class and then bring this behavior here. So that is possible here. Okay, say for example, now I am planning to define one method. So whenever you are creating a method in any of this, so you must have self. So here I have just created one student definition and the method add student. So then, okay, now if I go to now I am creating. So now what I have done, I just created a class already. This is inheriting here. So now let me create a obj to C1. If you see obj1, we have created for C1, and now you can see add student. So when you call this add student, what is happening? It is going to assign these values here. Means that is very clearly it is indicating that. So you have a P1 inheriting from here. Okay, and now even after creating object to C1, we are able to see this method here. Okay, so now what I am planning to do here is I am planning to now since we have inherited P1 here, if I say P1 dot, I can still see because currently you are in this C1. Okay, now when you say P1, P1 is coming over here. Now when I say P1 dot, you can still, you can see this add student over here. Means it is proving again. I'm just showing that what is inheritance behavior only. Okay. So now what I can do is, since we are just trying to add student self, it is here. Okay. Self dot h1, and we are adding these values into the add student here. So here, what I want to do, I want to bring this behavior here. So what can happen? P1 dot add student. So what happens when we P1, when you call this method, then only all these values will be assigned. Uh, if you are confused, let me, I'll take this example later. So what I am trying to do here, this class I am creating for student profile. So what is there in the student profile? You will have your hall ticket number, F name and all that. And this I am creating for, so this class I will add all the student profile details, and in this class I am going to add only address details. Okay, so this is our parent class where I am going to have all the profile details. And then here I am going to add student details. Then I want to print in this class, print student, means print full student. So what I can do now, this has only address and this has full, but you are inheriting this student profile. You are planning to inherit this behavior here. Right? It is like when you are defining or when you are designing a class, you have to understand what are the common properties you will be using in further additional classes. So that information you can keep in a base class or a parent class. Okay, and then on top of it, I want to extend this information or inherit this information into this class. Okay, and then finally print full details because you have something I need to take the profile here and address here and print full student. So now if I come here, I want to print ADDR1, you can directly get. Let's say for example, if I say print ADDR1. Why? Because it is here only. Now, so we have print full student. This is the method. So of course I have not added everything here. You just see only, print full details means I want to add these values here. Since it is inside of the student, so maybe now you'll get some error. I want to show that error. So print full student ADDR1. ADDR1 because in the method, right, always you have to use self. So that's why I am putting this name dot. So this is normal. It is nothing to do with inheritance because we are directly using outside variable here. So I am trying to put the name here. Now you can see address. So just notice class is having the base information, address details. Address I have given only address here and but I want to print full student detail. So address is anyway in this class, I am directly using it. But what additionally I need this information also, which is there in student profile. So I can say, okay, now when I say I'll get full detail. So this is everything is inheritance only. These are all different examples I am trying to show. And what is the real use cases of inheritance? So here, base class and derived class. In this, I'm getting something from the parent and I added something here and then using it. Similarly, so here to simplify and not to confuse, I am using this class variables or I can create method also. But to easily understand, okay, how this is getting inherited, okay, I'm just showing here. So now I can create one more class. So I'm planning to have student marks. This class will only have the marks. And now I want to define print student marks. So again, since you are calling from within the same, so I need to use this one. If we are defining here in the self, we can say self dot, but right now I'm using here. So object one address, it is created for address. I'm calling from the address. So now I'm going to create one more object, obj2 equal to student marks. Okay, now it is a independent because it is completely independent. Now I can say obj2 dot student marks. Okay, it is MKS1. Sorry. So now you got marks. So now you can see this is currently independent. So already we have seen main customer profile is getting to address. Okay, means we are inheriting this information to here, and we are able to print both of the information. So currently there is another class, and in this class we have only marks, and I'm able to print marks. But right now I don't know this marks belong to which student. So student details already there. So if there is no inheritance, I will end up with defining all these hall ticket numbers student profile here. But now we have the inheritance concept. So I don't need to repeat this class again. Okay. And this class again I'm using in the student mark. I'm trying to inherit. So this student profile have already inherited to student address. So now I am also inheriting to student marks. So what is the benefit I'll get? I'll get student marks, sorry, student profile dot hall ticket number. So anyway, we already have it. Let me copy paste. So in student marks, I'm taking marks from student marks class, but I'm taking the name full hall ticket number full name from the parent class. Now let's see hall ticket number, and even if you want. So this is one very classic example of inheritance. So we will try to define the base classes or a parent classes, which will have a common information can be shared across multiple classes. So currently we are not doing anything complex job here. We have something here, some variable. So this variable I am inheriting to student address, and the same variable I am trying to inherit to another class also, and then trying to print marks I have only in this class. Rest of the information I am getting from the others. So here I have only address, and the rest of the other information I am getting from here. So that way we are making it full. So this is the very simple concept of the inheritance. Okay, but generally just using this class variable, okay, maybe it not makes sense to inherit, but we can have different varieties of the methods implementation. Okay, so today also I'm stopping early today, and because this is important topic, we have to deal with very detail. So maybe for now I'll stop Okay, with this basic inheritance behavior. So tomorrow I'll give more examples and how we can define methods and how we can create because I can also have the constructor in this class, and then when we inherit how this constructor behavior will go, and how there are so many other aspects also there. And multiple inheritance means when you create one class, and if you want to inherit behavior from more than one class, here means I want to maybe currently only inherited one class. If you want to inherit more than one, that is also possible. All that we can discuss tomorrow. Okay, maybe we can have full class tomorrow.